Okay, let's start it. Good morning, everyone, and welcome to this panel discussion I have the pleasure today to moderate. My name is Letizia Tedesco. I'm a senior scientist of the Finnish Environment Institute and an adjunct professor at the University of Helsinki. They are both based in Helsinki, Finland. And I'm a biological oceanographer by background, but after so many years working with CIs, I consider myself actually a CI scientist. And my research particularly focuses on the impact of CI's changes on the marine ecosystems. I have the pleasure today to share the floor with these three panelists on site. We have one panelist, soon you will see her online. So our first panelist is Professor Stephanie Hahn from the Alfred Wegener Institute in Germany. Stephanie is a CS physicist and also holds a professorship in cryosphere science at the University of Hamburg. Her research focuses in Antarctic sea ice, which she has studied actually in more than 10 expeditions. And then we have Dr. Robbie Mallet. Robbie is a postdoctoral researcher at the Arctic University of Norway, based in Tromsø. And, sorry, this is Dustin's pro? Yeah. Robbie focused on Robbie studies sea ice behavior and properties using satellite and in-situ observation. And last year, he spent 8 months overwintering in Antarctica. And he's also a fellow of the IAS Cryosphere Working Group. And then we have Dr. Jacqueline Staffels from the University of Groningen in the Netherlands. She's a senior scientist and a lecturer. She's a marine biologist. And she's an expert on the role of microalgae in the regulation of climate gases, especially within the sea ice ecosystems. And then finally, online, we have Sean. You can see her, Dr. Sean Halley. She's based at the University of Edinburgh in the UK. She's a reader in marine science, and her research focuses on the processes supporting ecosystem in the Southern Ocean and the Arctic, and how these processes influence and are influenced by climate change. Sean has taken part in the last 3 COPs and is currently the co-chair of the Southern Ocean Observatory System, in short, SOOS. All right, and so this panel is organized by BAPSI. So BAPSI stands for Biochemical Exchange Processes at Sea Ice Interfaces. We are a large international network of polar scientists, and we are all dedicated to study sea ice biochemistry and sea ice processes. We do a lot of things for the scientific community, like publishing traditional papers, but we also pay a lot of attention to early career scientists and try to enhance their career path. As well, we try to make the sea ice topic accessible to younger generation. And we also target policymakers. We already published one policy brief, an Arctic policy brief, where we highlight the importance to consider sea ice biochemistry and ecosystems when we have to choose among mitigation adaptation strategies. And we are also preparing at the moment an Antarctic sea ice policy brief. And finally, it's the third year actually that we are a COP, and every year more with an increased number of events. If you want to have more information, could you please, sorry, I forgot about this. I have to change the slide myself, and it doesn't work. Yeah. All right, so if you want to know more, our website and our X profile. All right, so what we will do today, so we will walk you through some images, some striking images of sea ice changes together with my panelists. And what we hope to do, our goal is to try to showcase the importance of sea ice ecosystem and biochemistry and how they impact, our sea ice impact our climate, impact our ecosystem, and also impact actually all of us. So Well, without further ado, I would like to start this discussion. And well, the very first question that I have from my panelists here and for Shan, why is CS important and what is happening to CS in both hemispheres?
Hi, everyone. Thanks for coming. Yeah, we have some slides up here that were originally going to be animated, but they do the job static just fine, I think. So the important... Okay, so it's working. Fantastic. Okay, so we can see the typical distribution with a light blue line, and we can see how variable sea ice is from year to year. The really important thing is that it's very variable in Antarctica, but in the Arctic, we're seeing a very consistent decline. So quite different situations in both hemispheres that maybe we'll talk to later. But the real story is that when the sea ice shrinks, whether that's through variability or through climate change, we see a really radical impact on the surface sphere and the ecosystems that sit below. So all these systems are linked and they're mediated by the sea ice cover themselves. Can we have the next slide? One of the things that quite a lot is the way in which we observe the sea ice system from above. Maybe we'll try a different mic. Yeah. Let's try this. So we observe the sea ice system from above. And we have very, very good observing systems in the Arctic. So lots of global north countries live around the Arctic, and it's also an ocean enclosed by land. So it's very well observed by ships, but also by satellites because of just the way we've prioritized research historically. In the Southern Ocean around Antarctica, where there's just as much sea ice and in fact more at the seasonal maximum, it's very, very poorly observed in terms of what we know and how often we go there. So it's a really big theme in my research is figuring out how we can apply methods from the Northern Hemisphere to the Southern Hemisphere to figure out what's potentially actually a much more complex system that needs more research. Steffi, do you want to take the next one?
Yes, so maybe just like to get to this, okay, or to that one, that's also fine. Just like to the slide before, even that one, yes. So just like to extend here a little bit more on the evolution of the Antarctic sea ice area. So as Robbie already mentioned, so for the Arctic, we observed over the last decades this really, really strong decrease in the Arctic sea ice extent, meaning that we lost around about 50% of our Arctic summer sea ice cover. However, in the Southern Ocean, as you can see on the right-hand side, it was pretty consistent over quite a while. However, there it seems like changes just kicked in 2015-16, even though you can't see it now here on the screen, but just like trust me for the moment. So you just like take the next slide. So this is where we can see it. So we had this drastic change in the Southern Ocean now in the last 7-8 years. And as Robbie already mentioned, so it's really tough to estimate where this is coming from, given the fact that we have hardly any observations, in particular in the Southern Ocean, which is one of our big topics when doing polar science, when talking about Antarctic sea ice, and in particular the changes over the last years. In order to understand why the Southern Ocean and as well as the Arctic Ocean is so important, on the next slide, what you can see is the so-called ice albedo feedback. So meaning that our polar regions are kind of our fridges of our Earth, meaning that most of the incoming solar radiation is reflected back due to the white surface of the Arctic and Antarctic sea ice, as well as, of course, the ice caps of Antarctica and Greenland. However, now as the sea ice is shrinking, most of the incoming solar radiation is not reflected back anymore, but it's just like going into and absorbed by the upper ocean in the polar regions, which is heating up the system there, allowing for even more sea ice to melt and therefore to keep all the heat in the polar regions, which then causes in the end that we have this positive feedback loop, which is just like bringing more and more energy in the system and keeping all the energy in the system, which is why this is just like accelerating more and more and more, and which is why we in the end observe in the polar regions a much stronger climate change and warming of the regions compared to the global mean.
So going forward, since traditionally we have been told, I think for decades, that actually sea ice was, something biogeochemical inert, something really that nothing was going on. And nowadays we know that so much things actually are going on in there. So what does make polar oceans and sea ice so complex?
Yeah, that's a very important question, actually. As you mentioned, sea ice has been regarded as a cap on the ocean, and that was it, and a reflective thing. But it's much more, actually. So there is a very huge biomass of organisms are attached to that, and the moment you get everybody knows the whales and the polar bears in the Arctic, the enormous amount of krill that are actually dependent on the sea ice. But what happens when this sea ice changes? When there's less sea ice, that not only means that there's a less reflective surface, but it will also mean that more winds can start to impact on the ocean. It will impact on the fluxes of climate gases from the ocean into the atmosphere, or the other way around. It will result in changes in biomass of algae. It will change in species composition that are completely different, and the impact of that is that there is potentially much less CO2 being taken up by organisms, by algae. They are the primary capturers of CO2. They are not able to produce their gases that are involved in cloud condensation nuclei. So the production of clouds, especially in the Southern Ocean, is largely part of the whole ecosystem. That's actually the middle arrow. So if all that changes, then it will impact on climate, and this is something I haven't heard in this meeting at all, actually. So what we expect that there is a lot of things are going to change when sea ice cover changes. It will some of the processes will go down, some of the processes will go up. But as you see in this slide, there are also a lot of white arrow marks. We simply don't know what the impact will be. And as long as we don't know that, we are just baffled about what climate change how that will feed back on the system and how that will feed back on climate itself again.
Yeah, so narrowing a bit down. So if we focus on the Southern Ocean, how is actually Southern Ocean so important to nature? What kind of roles the Southern Ocean play? And maybe Sean, if you can hear us and you wanna also.
And good morning, everybody. It's really nice to be here with you, albeit online. I hope you're all having a great conference. So to speak to why the Southern Ocean is important for nature, this is really about the immense productivity of this system, which rivals that of continental shelf ecosystems in the tropical oceans, which of course get much more press, but the polar oceans have an equivalent productivity and an equivalent importance. And they're also incredibly rich and biodiverse with the types of life that they support. So the ecosystems in the Southern Ocean are fundamentally important, both regionally within the Southern Ocean itself, but also globally, because many of the organisms that live in the Southern Ocean migrate in and out every year. So this connects the Southern Ocean ecosystem to ecosystems as far away as the coasts of Brazil and California, because of the animals traveling between the Southern Ocean and the lower latitudes. And similarly, the Southern Ocean acts as a supply mechanism for nutrients to the entire global oceans. So in that way, it fuels life elsewhere throughout the global ocean system. Now, what I wanted to particularly bring out in this image here we can see that it is a schematic diagram of a Southern Ocean food web. And the key point here is how interconnected all of these different components of the system are. And they are intrinsically linked to the sea ice cover that my colleagues have been talking about so far. So we can see that the sea ice algal bloom that Jacqueline talked about and the phytoplankton bloom, signaled by the green splodge in the middle of this image, they are the base of the food chain that provide food for all life, both within and beyond the Southern Ocean. And they are fundamentally controlled by the annual advance and retreat of the sea ice. So if this sea ice is changing, which we know it is through the presentations that Steffi and Robbie have given, then we know that that will have fundamental impacts on the ecosystem. And because of this great interconnected nature of the system, a change in one part of the system will have cascading effects throughout the entire system. And it's important to note that in addition to the sea ice declines that we're focusing on in this session, the Southern Ocean is also under immense pressure from warming, freshening because of ice losses, and the acidification of the oceans, which I'm sure has been a big topic in the Ocean Pavilion. So it's the combination of these stressors that is really putting these ecosystems under immense amount of threat that derives ultimately from climate change and us driving the problem.
Thanks, Sean. And I would like to ask you, because we are a COP, since the Southern Ocean, it's not only important for the ecosystem it sustains, but it's also important for all of us. And this is sometimes difficult to explain because we are so unconnected. They seem so far away. Would you like to explain us how actually the Southern Ocean is important for all of us in this room? And could you please?
Yes, of course. So that's the next slide, please, which is the same image again, but just resized slightly with some key text around it. Yeah, thank you. That's the right one. So this aims to show the ecosystem services of the Southern Ocean, which are the fundamental reasons that the Southern Ocean is important to people everywhere. And for those of us living in the Northern Hemisphere, like myself in Edinburgh, we might think of the Southern Ocean as quite far away and perhaps not so relevant. But actually, there are a huge number of people who live in South America, Australasia, Southern Africa, who are much more closely connected to the Southern Ocean than we are in the global North. So I think it's important to remember that global South countries arguably have a greater connection to the Southern Ocean than those in the Northern Hemisphere. But regardless of that, Southern Ocean processes actually affect people everywhere. And that's through 4 main mechanisms. So we have the biodiversity that I've already talked about. And this is an ecosystem service, partly for its intrinsic value, but also because of its cultural value that it provides to human beings. We also have blue carbon and climate regulation. So the Southern Ocean takes up a huge amount of the carbon dioxide that we emit. And it does this on an annual basis through the biological processes that Jacqueline talked about, as well as physical processes where CO2 is dissolved in the upper ocean. So the Southern Ocean does us a significant climate service in taking up a vast amount of carbon dioxide and therefore protecting us from even worse climate change than we are currently experiencing. But it's important to note that as climate change proceeds, the variability of the Southern Ocean to do this is reduced because the processes that take up the carbon are put under pressure and under threat by the changes that are occurring. And it's this uptake of carbon dioxide that is the primary driver for ocean acidification, which is one of the most severe threats to the Southern Ocean. So we have these ecosystem services that have served us incredibly well but themselves are under threat because of the warming and other associated climate impacts on the Southern Ocean. So I mentioned that the Southern Ocean is also a fuel source for nutrients for the global ocean, and this ultimately means that it supports the health of the ocean worldwide. And as everybody in this pavilion, I'm sure, will know, the health of the ocean is absolutely fundamental in underpinning the health of humanity at the global scale. And then in terms of the provisions that the Southern Ocean provides, there are several commercially important fisheries species, including the Antarctic krill and the toothfish species, which are commercially harvested by several nations and therefore are important in underpinning food security, and also because of the role of the Southern Ocean in providing nutrients to support ocean life throughout the lower latitudes. That also gives the Southern Ocean a very important role in underpinning food supply and food security worldwide. So all of these ecosystem services are very important to humanity in different ways, but they are all under threat from the combined impacts of warming, sea ice loss, which we're talking about in this session, the freshening of the ocean, and the acidification of the ocean. And the only way to safeguard these Southern Ocean ecosystems and the immense benefits that they provide to humanity worldwide is to limit warming to 1.5 degrees above pre-industrial levels.
Thank you so much, Sean. So if you could go back to the slides, please. So I would like to move to the other side of the globe, and I would like to ask you how this is different, how the Arctic Ocean is important for nature and for people.
Yeah, so that was an excellent summary of ecosystem services of the Southern Ocean, Sean. Of course, similar processes are taking place in the Arctic, which I don't need to reiterate, but what is a big difference between the Arctic and the Antarctic is that it's a totally different ecosystem. And that also means that there are different sort of so-called top predators. In the Arctic, it's the polar bear, of course, that is very dependent on sea ice systems, and the polar cod, which is of immense importance for indigenous peoples to survive. And that brings me also to the fact that people have in the Arctic a much greater are much more impacted by all the changes in ecosystem services. Especially, of course, the indigenous peoples. There's about 4 million, and actually yesterday I heard it's actually 7 million people living around the Arctic system. It's their hunting grounds, it's their livelihoods, it's the sea ice provides their transportation means. And that's only the sea ice. I'm not even talking about the permafrost and all the things that are happening on the environment around the sea ice. But it's for them, there are incredibly things happening over there, and denying or not taking that into consideration would be a very big mistake. And I can only reiterate what Sean said. We cannot afford to get the globe warm beyond this 1.5 degrees. It's our responsibility also for the people around the Arctic to make sure that doesn't happen.
So we understand now better how the system works, what are the components. The next question, what about the future? What about the future of sea ice?
Yeah, so we have quite good models for Arctic sea ice now. The latest generation of climate models matches the observations reasonably well. so we can forecast the Arctic sea ice with some confidence under different emission scenarios. And we do see quite a divergence by the end of the century that under high emission scenarios, so 7 watts per square meter forcing 8.5, these RCPs or SSPs that you hear about, we do lose essentially all of the summer sea ice in the Arctic by the end of the century. But we find quite a clear difference with these low scenarios in blue, SSP 1.9, SSP 2.6. We can actually have quite a big impact just by capping global temperatures to 1.5 or slightly above. But when we move towards 2 degrees, which is represented by the orange and red scenarios, we do lose it. So it's kind of it feels sometimes like it's a very grim story, but it turns out when you look at the models, we do actually have a surprising amount of control, but that control is rapidly lost after we exceed 1.5 degrees of warming. I wish I could show you a similar graph for Antarctica, but we have a much more greatly degraded ability to forecast Antarctic sea ice. So I would say Antarctic sea ice, the way forward in my mind is a precautionary principle. So we shouldn't look at the uncertainty in Antarctic sea ice and say, oh, well, it doesn't matter then, does it? If we don't know what's going to happen, we might as well just roll the dice. The issue is, as we've said, because of the huge gaps in our knowledge of how Antarctic sea ice is going to respond in future, we really shouldn't roll the dice, right? We should play it safe and act to cap emissions in a way that is going to protect the Arctic sea ice and protect us from a dangerously unpredictable climate system in the southern hemisphere. Do you want to say anything about that, Steffi?
Yes, and maybe just like to finish that up at some point, at that point. So we talked about the importance of the polar regions, not only for the polar regions themselves, but really also on a global scale. So when we now see that the sea ice in the Arctic is changing so drastically, as it is currently the case, we know that already now around about 20 to 25% of the cooling effect that the Arctic is doing, like for our whole globe, is already reduced, which means in the end that what I just said before, that we keep all this energy like even more in our system. For the Antarctic, as Robbie said, even though our model predictions are like really, really bad so far because we have hardly any observations and have hardly a good understanding of what is happening in the Antarctic region in terms of interaction with the whole coupled climate system, we still observe also now a change in the sea ice cover, and that we have also there the reduction currently, which leads in the end currently to a loss of cooling of our whole globe of around about 10%, which just like shows how important the polar regions are and what is the huge impact of the change of the polar regions for our whole global climate system.
Thank you, Steffi. So we are approaching the end of our journey into the sea ice world, and the last thing maybe that which is very important because we are a COP. So what are the options? Do we have any solution to this? How can we protect sea ice?
Well, I can actually only reiterate that we need to keep the temperature below 1.5 degrees, and if we don't, there are geoengineering options that we are currently talking about, because some people think we won't make it. So we need to start engineering our environment for our sake to prevent it from happening. But that's not going to work if we are not able to keep the temperature low, because then every year we'll have to do more and more to overcome the impact of the warming. That's basically I'm sure that probably Sean might want to have a go on geoengineering options that are currently mentioned. And I rather want to give her the floor for that, because for me, that's not an option. Sean, go ahead.
Thank you, Jacqueline. Yes, I would like to make it very clear that geoengineering sea ice is not a viable solution. And the disadvantage of being online is that I can't see who's in the room. So I suspect there may be some people in the room with an interest in geoengineering. So I say what I say with that in mind, and coming from a standpoint of scientific objectivity and perhaps a reality check on some of these geoengineering ideas. So geoengineering has gathered pace over the last 3 COPs. I personally witnessed a huge acceleration in talk about geoengineering approaches, and there have been several approaches proposed. So for sea ice, there are 2 approaches that are primarily being pushed. So these are increasing the albedo, the reflectivity of the sea ice that Steffi talked about, and artificially thickening the ice by pumping seawater onto the ice surface over winter so that it lasts longer over summer, or indeed pumping seawater into the atmosphere above the sea ice so that it freezes and falls as snow and thereby thickens the ice. And the idea to increase the reflectivity is by scattering glass microspheres across vast areas of the surface of Arctic sea ice. And the overriding issue with both of these approaches is just that they're very unlikely to work. And let me explain what I mean by this. So I'm not saying that we can't pump some seawater onto ice and thicken it. I'm sure that does work. I'm sure that scattering glass beads does increase the reflectivity. But what we're talking about here is a huge scaling issue. So when I say they're very unlikely to work, what I mean is that it's almost impossible to see how either of these approaches will make an appreciable difference to the climate and sea ice trends that we're witnessing. And that's because it's almost impossible to see how they'll be deployed at the rate and the scale to make any meaningful difference. So, for example, with the sea ice thickening approach, I should back up a little bit. There has recently been a paper published led by Martin Siegert, which included many scientists from around the world to try to provide some scientific objectivity to the sea ice geoengineering debate, and to provide a scientifically informed reality check. And we investigated these 2 sea ice approaches, among others, and it was this comprehensive and objective test that was not passed by any of the proposed geoengineering approaches focused on the polar regions. I know there's lots of sessions in the Ocean Pavilion about marine carbon dioxide removal. I'm not talking about that. I'm talking about approaches proposed for the polar regions. So for the sea ice thickening approach, we estimated optimistically that one sea ice pumping, surface water pumping device to thicken the sea ice could perhaps cover 1 square kilometre, maybe, if we're really optimistic. That would mean that over 10 million devices are required for the current winter sea ice cover in the Arctic. Now, there is a study that says that if we only covered 10% of that sea ice, there would be an appreciable difference in terms of the climate. So if we believe that, then we still need 1 million devices. And let's say, very optimistically, we can perhaps deploy 1,000 devices per year. That still means that it will take 1,000 years to deploy this technology at the scale required, by which stage there is the sea ice is likely to be vastly changed from what it is now. And in terms of the glass beads to increase the albedo of sea ice, it is thought that approximately 360 megatons of glass beads, million tons of glass beads, will be required per year. Now, this is approximately equivalent to the current annual production of plastic worldwide. So not only is this a huge logistical challenge, but it's also would be deliberately polluting a very sensitive marine environment, and would be creating huge carbon emissions during the production of those beads. So not only are these technologies and these approaches very unlikely to make a difference to the sea ice trends that we're seeing, but they also have very serious risks attached to them and many negative, perhaps unintended consequences. And of course, with the Arctic being a fairly complicated place in terms of governance at the international scale, any direct intervention in this very fragile system is going to have major governance issues in what is an increasingly congested and contested space. And of course, first and foremost, among all of these discussions, we need to be thinking about the indigenous communities that Jacqueline referred to, and their position in a debate which really will have direct effects on interfering with their Arctic homeland. So the conclusions of our paper and of many, many scientists working in the polar regions is that geoengineering approaches for sea ice and other approaches for the polar regions are just not a viable solution.
Thank you so much, Sean. So Robbie, please go ahead.
I just wanted to add one thing about the composition of the panel. So not all CI scientists are field scientists, but it just happens by the way it's worked out that all 5 of us are. We all have a hat where we wear when we go out on the sea ice and install instruments and measure what's going on. And it is quite striking that nobody really ever asks us from these groups that are planning to spread the beads and install the pumps what it was like. So they operate in quite a siloed fashion from the community of people whose job it is to actually go out there and work on the sea ice. And I think that, I don't want to speculate why that is, but I will say that we have experience of it being extremely difficult, right? So the picture on the last slide is in a fairly sheltered fjord in Svalbard, but most of the Arctic is not like that. It's an extremely difficult place to work, and even more so in Antarctica. So I just want to stress while we're all here, and I think everyone will agree with this, the logistical and just physiological difficulty of deploying any kind of intervention like this it's just impossibly difficult.
Thank you so much, Robbie. So as I said, we are at the end of this journey into the CS world, and we want to leave you with these take-home messages, which maybe I just want to going through with you. So I hope by now you know that we are really losing a unique habitat, which is comparable to the destruction of coral reef and tropical forest. And please take a moment to reflect about what I just said. And the actual feedback of sea ice changing into the global climate are still largely unknown. We need to still do a lot. And we want to reiterate once again that we really urge to keep the 1.5 degree warming we cannot go over. And finally, as a sea ice scientist, from our scientific and objective point of view, it really seems that sea ice geoengineering is no option. And I want to thank you, my panelists, but then I would like to give you the word to the audience for question. And if you could please put Shan and stop sharing so we can also see her. Are there any questions from the audience?
Hi, great presentations, conversation. This is Amina Shardab, Scripps Institution of Oceanography. I was just wondering if you could comment a little bit, because I haven't heard of these geoengineering pumping sea ice. I've been trying to install a pump on the Scripps Pier to pump water from like just a few meters down, and they break down in just a few weeks because, salt water is a really difficult thing to work with. And then these low temperatures are just going to make it really, really extremely difficult. So, right, I imagine a bunch of littered pumps all over the Arctic that will last about a couple weeks. What is the thinking about, like, what kind of pumps are they thinking they're going to set up there? They're going to function with seawater in an Arctic winter?
The one that was tested in the picture that you saw is just a fairly standard diesel pump, which is obviously ironic given the situation with diesel, but also the way that air pollution is produced, and it can interfere with the cloud regime. It can deposit on the snow, which lowers the albedo. So it doesn't work very well. But I mean, we have a lot of experience, the people on the panel, with petrol and diesel powered drilling machines. So we drill hundreds of holes in the ice all the time, and it's really hard. These things break all the time. The number of ripcord flown off is beyond counting. So yeah, I mean, internal combustion engines on sea ice are a nightmare.
Would you like to add something, Sean?
I think Robbie's covered the technical side, and indeed the person who asked the question answered it herself, really. The only other thing that I would add is that pumping seawater has an incredibly detrimental effect on the seawater ecosystem and the stability of the sea ice ecosystem and the dynamical processes that occur in the lower atmosphere, which connect the atmosphere, the sea ice, and the ocean. So the pumping, whilst likely to be short-lived, as has been suggested, will have a significantly damaging effect on the ecosystem whilst it is working. And I think on the scalability point, it's often lost that deploying either of these approaches will involve human presence and a human interference with the Arctic, which is just completely off the scale of what has ever been achieved before. And another major issue is that sea ice breaks up, it moves around, it melts. So the possibility of these pumps just sinking through the ice and being dropped into the ocean is very real and will cause a significant secondary issue. So the human presence and the rate of loss, I think, has not been appreciated at all, and the governance issues around those are incredibly complicated in, as I said earlier, what is an increasingly congested and contested space.
Thank you, Sean. I would like to add, and thank you for bringing on also the fact that all of these geoengineering options hopefully don't really take into consideration the impact of the ecosystems. And this is what we are really trying to also, raise this awareness. And in fact, it was already a few years ago that we at BAPSI published a paper where we addressed the consequences of these two methods on the ecosystem, how all the system would change. And we really don't know when a change is so abrupt what's going to happen. Any other question? Yeah.
Hello, I was just curious how indigenous voices and citizen science is being used in some of those hard to reach areas, either more probably in the northern oceans, to improve data collection. As I was kind of something you mentioned, like all the panelists, that there's not the best data all the time, and then there's just some gaps. So how are those voices being utilized to kind of help close some of those gaps within the oceans?
Well, maybe I can just answer that for the Arctic sea ice thickness, actually. So we have close collaborations with the local people when they cross their fjords, that they would pull instruments measuring sea ice thickness behind them. And this is, on the one hand, it's for us valid data, but on the other hand, it's also for them in terms of safety, in order to see that it is safe what they are doing. So therefore, we really use these connections, and we are really, kind of happy and proud to say that we are really working together with them, both for the benefit of them, but also for the benefit of science, for the additional data.
Maybe I can add, it's not my field of work, but I think as BAPSI we can mention the work that our colleague is doing, and in Canada they have a very good relationship with indigenous peoples, and they have worked with them together to produce a calendar, an indigenous calendar to show them when things are changing, and that was a very, very I would say an impressive achievement. I'm not sure if it's being published in any ways, but
Not yet. It's work in progress.
Yeah, but we are doing our best, definitely, yes. I would say.
And I think there is more and more of this knowledge sharing, which is also very important. I think where there is more and more, there's been more and more also projects in science where we take their knowledge and we take it into consideration, which hasn't been actually done before. Yeah. Oh, sorry, Shan, go ahead.
Yeah, thank you. Just to add something on the Southern Ocean, as you, as the person who asked the question said, it's not, citizen science isn't so widespread, but actually there are examples. So there's a project in coastal fjords along the Antarctic Peninsula where tourist vessels get involved in the collection of data. And this is in collaboration with a colleague who I think is based at Scripps, Maria Vernay. Some of you may know her. She is running a citizen science program where data is collected from tourist vessels and quality controlled and made available for use by scientists. There's also been some scoping work done actually by one of my students who has done interviews and surveys of people working in the tourist industry and the fisheries industry, both of which are increasing in the Southern Ocean, to explore their willingness to collect data for scientific purposes. And the results of that study showed that these different parties are very much willing, they just don't know what the pathways are to achieve that. So now there are efforts going on within the Southern Ocean observing system to make those connections and turn those tourist vessels and those fisheries vessels into a resource that can be meaningfully and usefully used by the scientific community in equitable collaboration to benefit the tourist and fisheries industries as well.
Thank you, Shan. Yes, please.
Hi there, Rolf Reuner from the Arctic Mountain Assessment Program. First, we'd like to thank all the panelists for excellent presentations, and Sean, also good to see you here at the COP, though remotely. Yesterday, we launched the first findings from our common climate update report, and they resemble very much what's said here. I mean, since 1979, we lost sea ice of an area the size of India, and we lose more or less the size of Scotland every year. So it's happening really fast. And at the same time, we have other processes. The ocean acidification is happening 3 to 4 times as fast in Arctic as anywhere else. We have species dislocation. We have increased vertical mixing through the water column, and invasive species and so on. And my question with regards to that is to Jacqueline. You mentioned the feedbacks, and we also right now we're undertaking an assessment on climate impacts on ecosystems and their feedbacks back to climate systems. As you rightly said, it's really complex. But given those different processes, is it possible for you to kind of sketch up which processes would be positive when it comes to the feedback, and you can define yourself whether it's positive in a good way or in a bad way, and which will be negative?
Yeah, it's an excellent question, and it's what we are working on. I should mention at least 2 things: is that Antarctica and the Arctic is totally different. If I'm less of an expert in the Arctic, but we know that the Arctic is very nutrient poor. So a retreat of the sea ice will most probably result in, I would say, in less biomass, because there's hardly any sea ice that can see the surroundings. Although there's also actually modeling work that thinks that potentially there is more biomass, more algae being produced. But what is most important, that a change in the sea ice system will result also in a change in the phytoplankton composition. And I would think, but I'm not totally sure how it would result, that at some point we will get a decoupling from sea ice that is produced, that is growing around the shelf regions, and what is happening in the Central Arctic. And that will be totally different. And what will happen in the shelf areas is probably that there will be an increase of production of organisms that are capable of producing these climate gases that contribute to cloud formation, whereas in the central Arctic I would expect a decline. I can't. It's very hard to substantiate that. For the Antarctic, it's different. We currently, Antarctica is one of the biggest sources of these cloud condensation nuclei, and a reduction, and the sea ice ecosystem is incredibly important for that to develop. If sea ice starts to retreat, it might very well happen that blooms of these algae that are specific for the formation of cloud condensation nuclei are actually vanishing, or they appear in a moment in time that it's less relevant compared to what we see now. There are huge changes to be expected, and so all in all, I think we really know so little. The production in the sea ice is grossly underestimated in the Antarctic. I'm quite sure. So we expect a lot of increase in the surface, in the water itself, but less in the ice. So the net result, I'm afraid I really can't say. And we were working hard on that, but it's you could say in one go, if there's less ice, then there will be less of a source, because the ice creates the source. But that's a very, very big leap to take.
If I can just add something, so we look into the future of sea ice in the Arctic from a biochemical point of view. Some years ago, I think it was 2020, we published a paper that Finland Uzal, which is also with us in BAPSI, was the first author in natural climate change. And we have taken into consideration all indicators from physical to chemical to biochemical and biological, and try to make an assessment based on what we know. And I must say that with different kind of confidence level. And there was a kind of something we know, we are more confident. Many things still we don't know. We kind of really at the direction even. So, and we are producing a similar paper, which is even more challenging for Antarctic sea ice. We are still familiar. So if someone has some, Sean? Sorry, I don't see you so much from my stage.
Thank you to whoever in the audience keeps pointing to me. I just wanted to add that I think Rolf's question is really important in terms of the entire Arctic, but for the people who live there, actually what's happening in their local area and the surrounding region is really important. And with ocean acidification in particular, this is undermining their food supply. And it's not only food, it's culture and livelihood as well. So I think whilst it's tempting in policy spheres, and particularly global climate ones like the UNFCCC COPs, it's tempting to think of the Arctic as one big machine. But actually, we need to think of it as a complete mosaic of quite different systems which have different needs and are changing in different ways. And we really need to place at the forefront of our minds the ecosystems within each of those smaller areas and the people that rely on those ecosystems. And certainly for many of the northern communities, the changes that are happening in their local area and the region that affects them, the changes are negative and they are rapidly accelerating negative. So that really, for me, underscores the fundamental need to stick to 1.5.
Yeah, and on your positive side, I don't think we have seen any positive side of the story, at least not yet. All right. Yes, please.
Hi there, I'm Narissa Bax. I'm based in Greenland, so working at the Institute for Natural Resources. And I come from more of a polar marine background, but I wasn't aware of the geoengineering for the sea ice. And so obviously there's a very clear interlinkage and bigger conversation that seems to be emerging here as well. And something that I was talking about just before this session was that apparently there is sort of a shift to allow for some freedom of the methodology in the text at the moment for what these could include. And so I just wondered if anyone on the panel had any sort of insight into how we can shift to have some boundaries around that and have it more science informed, because it does seem like it could be a risk for these environments.
It is a risk. Robbie.
I was just going to say, I think in the 2010 version of the UN Convention on Biodiversity, there is actually a line about it, and that doesn't get nearly as much attention as it should, where geoengineering is essentially outlawed at the state level, is my understanding. But in terms of governance, it's like, how can we get an effective framework around it? It is a challenge, and at some point the scientific community is going to have to decide whether it engages with that process, because at the moment it hasn't particularly engaged in setting boundaries, in the concern that by setting those boundaries you de facto create a space. So I haven't seen any indication that large groups of scientists are going to go for that in terms of creating what some would term a safe space for geoengineering, like select methods. I think we're still some way off.
I guess I was talking from the flip side of that, though, more so what we can do to make sure that there isn't room for that, where people are trying to make space for that.
If I can just add something, I think one thing is important nowadays is that we cannot, as scientists, we cannot ignore this anymore, because there are still scientists who don't want to have anything to do with the topic, but I think we cannot ignore it because it's going on. So what we can do is just to try to, like we are trying to do, to be objective and just point to the science behind. And there are big organizations like AGU, for example, that they are discussing some kind of ethics around this topic. So something I think is moving in the right direction, and we absolutely need some governance and this kind of, because otherwise they actually are really out there. They are testing these, and it goes very fast every couple more. So, all right, I think we need to close. I would like to thank you, all of you, for coming. I would like to thank you, my panelists. I would like to thank you, Sean. And if you have any questions for us, we will be still around for half an hour. Thank you.